we could hear the platform breaking up. We could hear almost as if the welding joints were melting, and it was then, I think, that a few of us shook hands with each other, not knowing what was going to happen.
I could see people standing on the spider deck and a few people in the water, and then you got the huge gas explosion and the fire came right down to the water. When it receded, there was nobody stood on the spider deck anymore.
On July 6, 1988, 167 men died in a fire on board Piper Alpha, a North Sea platform. This incident should serve as a constant reminder to all of us in E&P that we're working with forms of energy that, if not controlled, can have devastating effects. Later in this programme, we'll be going to Egypt to look at an incident that, like Piper Alpha, involved the release of hydrocarbons and a major fire, although in this case a disaster was just avoided. In this, the third topic of our immersion series, we're looking at energy isolation. This means controlling not just the chemical energy stored in hydrocarbons, but all of the energy forms we deal with. In general, any form of energy is safe if the system containing it has been well designed, constructed and maintained. The real danger occurs when any human interaction with that system takes place, and that's when the golden rules of safety on energy isolation must be applied.
The golden rules of safety for energy isolation state that any isolation of energy systems, mechanical, electrical, process, hydraulic and others, cannot proceed unless the method of isolation and discharge of stored energy are agreed and executed by a competent person. Any stored energy is discharged. A system of locks and tags is utilized at isolation points. A test is conducted to ensure the isolation is effective. Isolation effectiveness is periodically monitored. If any of these steps are ignored, the results can be devastating. In E&P, we deal with a wide variety of energy forms every day. Take a typical offshore installation, for example, including the derrick, pipe store, generators, production modules, offices and accommodation. Just about every energy source imaginable is present. The same goes for other E&P locations, from wellheads to production facilities, maintenance and storage areas to domestic and office environments. All have their own stored energy hazards. The release of energy from chemicals is a danger wherever acids, alkalis or oxidizing agents are used or stored. Fire is a chemical reaction and a potent hazard in E&P, as are the blasts from the combination of chemicals and explosives which are commonplace in seismic and well operations. The release of energy from radioactive sources, such as some instrumentation systems, is invisible but no less harmful. Electrical energy powers a vast range of systems in every E&P operation, from high voltage DC supplies to the lower voltage AC power used in offices and in our homes, but which is equally dangerous. Mechanical energy is present in almost all operating machinery. Springs, cables, any mechanism under tension or restraint has the capacity for sudden release unless the stored energy is isolated and made safe. Mechanical energy stored in hydraulic and pneumatic systems is also commonplace, especially in control networks. And all over E&P, energy is stored in fluids such as oil and gas, under pressure in pipes and vessels, with potentially serious consequences for anyone not following the correct isolation procedures. The October complex is a platform in the Gulf of Suez operated by GUPCO, where BP is a 50% partner. This long-established platform has been producing around 60,000 barrels of oil a day, with associated gas. In May 2001, a program of work was underway to replace pressure safety valves on the separators on the platform. There are 5 separators, and a general work procedure had been drawn up.
في خلال نفس الأسبوع اللي عمل دون كان تم عمل صيانة لنفس الشغلانة دي على السبريتور رقم 1 وعلى السبريتور رقم 2 وده السبريتور رقم 3. عملت بكذا مرة وتعتبر روتين وورك يعني مش جديدة علينا.
In the Gulf of Suez, the platforms have no accommodation, so the entire crew changes on a shift basis. A permit to work document had already been prepared at the onshore office. The electrical and instrument staff and the operators held a pre-job safety meeting.
السيفتي ريليف فالف بالنسبة للتست سيبريتور 103. فطبعا زي البروسيدور ما هو موجود الايزوليشن بروسيدور هيتم العزل، هيتم عمل اللوك اوت والتاج اوت. بعد كده هنقعد فترة انتظار تو تشيك بريشر بيلد اب من 15 ل 20 دقيقة. لو الاوكي العزل يبقى هنبتدي نعمل درين للسيستم لغاية ما نتأكد انه زيرو بريشر زيرو ليفل.
And at 10 o'clock, work started to isolate separator V103. When the crew thought they had isolated the vessel, the actual work of replacing the valve began. At 11 a.m., the foreman called the shore base to explain that all was well. He had no idea of what was to come.
بدأنا نفك البولس الموجودة بتاعت السيفتي ريليف. بعد ساعة وتلت تقريبا من الشغل بتاعنا تقريبا كنا خلصنا فك، ونزلت انا عشان اجهز الكرين عشان نرفع الاثنين سيفتي. فبعد ما نزلت مباشرة ورايح اشوف الراجل بتاع الوناش حصل الموضوع ده.
ما بقيناش شايفين قدامنا وازاي ده جه ومنين، يعني حصل ان الواحد في لحظة ما كانش متوقع ابدا ايه اللي ممكن يحصل نتيجة الزيت دون.
The crew on the October platform thought they had done everything needed to isolate the energy in the system. But the subsequent investigation found that a drawing showing all connections to the separator was not available to those performing the isolation. The isolation procedures that were in place were not fully utilized. Some valves were not locked, and the air supply to the actuated inlet valve was not positively disconnected. The result was an uncontrolled release of energy that had extremely serious consequences, as we shall see later in this program. The energy involved in the October complex incident was stored in fluids under pressure on the platform. In the Algerian BU, it was the failure to isolate the mechanical or gravitational energy in a raised load that caused a fatality associated with the Insala project. In February 2003, Hamida Lubar was examining the hydraulic system of a tipper truck. He'd failed to notify his supervisor that he was about to make repairs, and having raised the tipper, he leaned under it without making sure the mechanical energy stored in the raised bed was isolated with a support brace.
قلت لك كي سمعنا بهذاك الحس هكا اونيتي بارور تبي سمعنا لو نون تاع اكسيدون جرينا كي جرينا خرجنا ديريكتومون لاغري حبس لاغري يقول لك كاين واحد رايح عليه لابان طايحه عليه لابان. جريت حضرت مع الكريتي هو خرج من لاغري كانت بيان كاري هنايا. خرجنا كي خرجنا هنايا بلاصيت لي زيلانك مي كي بلاصيت لي زيلانك طلعت الفوق بلاصيت لي زيلانك اون بيان في دو نيفو الوسمه تاعنا بور نو با ابيمي لو كور فهمت. وليت نطلع فيه غير بشويه افيك لي جيست غير بشويه كي طلع مليح. جا لا فيرمي والامبيلونس وكاع رفدوه اوكان جيست حنا كي حكمنا هكا لا الوسمه فوق ما يبانناش. il a fait كي قلباتها منا il a fait le geste pour sortir ما قدرش ديجا راهي حكمته منا دو كوتي فهمت كيفاش دابري سكون كومبري. مين جاي يخرج الى با لا مان دروا لا مان غوش لا مان دروات داخل ولا مان غوش برا pour sortir il a pas pu. C'était trop.
The job had not been evaluated for potential hazards as directed by the golden rules of safety. If the support brace had been in place, it would have held the bed of the truck safely in position, and Mr. Lubar would still be going home to his family today.
Il faut faire très attention pour la safety. باغ اكزومبل واحد الانسان يبغي يطلع البانه ولا يفو فير لا سيكوريتي ما يامنش في الوسمه يقدر يدير دي كال بيان كوم يلفو يكونترولي تاع الوسمه تاعو بيان كوم يلفو ويخدم على روحه.
This incident, as well as the one on the October complex, occurred in industrial settings. But energy isolation procedure applies equally in office environments, where the hazards and the potential for injury or death are just as real. In 2000, at Galeota Point in Trinidad, BP was using contractors in the construction of a new office building. Afi Morgan and Abiko Hernandez were electricians brought in to fit fluorescent lights. They had to reach the junction boxes in the ceiling, and Afi was using a ladder. Afi and Abiko were working without switching off the electrical power. The permit for work specified isolating the electricity supply, but this requirement was not followed. It seems it was common local practice for electricians to work with the power on. They were also under pressure to get the job done.
We have the next 13 of these to do still, you know.
Yes, man. Just one more. One more.
He touched a live wire. His grasp on a sprinkler pipe had provided a pathway to earth for the current.
Albert! Albert, come quick!
What's happened?
I think he electrocuted himself.
Is he breathing?
I'm not sure.
Go and get help.
Afi was rushed to hospital, where staff spent 30 minutes trying to revive him, but their efforts were unsuccessful. Another tragic loss of life involving work on energy systems, resulting in a bereaved family, friends and colleagues. The death of Afi Morgan highlights the dangers that are present in all office environments, and the need to understand energy isolation doesn't stop when you leave work. Chemical energy is present in a wide range of domestic products, with the potential to cause serious injury if not handled carefully. Fire is a common form of chemical energy release, and it is vital that all flammable products, such as compressed gas, and all potential sources of fire, such as naked flames, are made safe at all times. Electrical energy is used in a wide range of appliances and systems in every home, whilst mechanical energy is also present in many everyday household items. If injury and even death are to be prevented, then the principles of energy isolation should be followed in the home, just as they should be in the work environment. The consequences of not doing so can be equally severe. From January 2001 to October 2004, 3 members of the workforce died in energy isolation incidents in E&P. In total, there were 58 high-severity incidents. 25 involved electrical energy, with 16% of these occurring in a domestic setting. 26 incidents involved materials under pressure. 5 involved release, fire or explosion, and 2 involved mechanical energy sources. As we move forward, we must learn the lessons from all of these incidents and make sure that we fully implement the golden rules of safety. One of the most important aspects of this is the ability to identify the potential for injury associated with all energy sources, even those that may not immediately seem dangerous.
The need to recognise all forms of energy in any environment and apply the golden safety rules before any work is started is vital. The Algeria and Trinidad case studies we've just seen were preceded by the incident on the October platform. What started as an escape of hydrocarbons soon became a matter of life and death.
ان واحد نازل بيجري بسرعة كده متغرق زيت وبيجري ناحية الكنترول، قال لي المحطة غرقانة زيت فوق. فكان من البديهي اول رد فعل ليا ان انا بسرعة احاول اشوف ايه اللي حصل او ايه اللي فيه ايه بالظبط. طلعت بسرعة على فوق. فوجئت بان في نافورة زيت كبيرة جدا طالعة من السبريتور ومغرقة المكان كله.
اول حاجة ان نعمل شت داون للبلاتفورم، دي كانت اول حاجة. طبعا وقتها طبعا ما كنتش اقدر اعمل انا شت داون، او لان احنا بنطلع محطات كتير جدا، فدايما اللي كان بياخد قرار الشت داون الفورمان بتاع المحطة.
السبريتور 103 في ليك في السبريتور 103 من ناحيه السيفتي ريليف فالف.
في ليك كتير جدا فوق.
The foreman was informed and called the shore base to report and ask for instruction.
دلوقتي احنا عندنا ليك الفلانشه بتاعت السبريتور 103 بتاعت السيفتي ريليف.
He was told to check the leak and report back. Having large amounts of escaped oil and gas are bad enough, but the problems on the October complex were about to become far worse. About 5 meters away was a glycol heater lit by a flame.
فما كان من النتيجة ان في لحظة لقينا ان الفاير لقط الزيت من النار، فبدأت العملية تخش بطريقة كأن بالظبط نار جهنم ولعة قدامنا.
ايوه في ايه عندك فوق؟ في ايه؟ في 103 حريقة؟ طيب ماشي. في حريقة في 103.
دلوقتي انا عندي فاير بالنسبة للسبريتور 103. اوكي.
قلت بقى على صوتي ان المحطة ولعت. نفس اللحظة حصل ان المحطة وقفت كلها وما لقيتش حد في الكنترول. كل اللي كان في الكنترول موجود ساعتها ساب الكنترول وخرج بره. طبعا بسرعة توجهت على الراديو، حولته على البي 1 اللي هي قناة الطوارئ عندنا. كلمت الراديو روم، بلغت من الموقف. طبعا انا ساعتها يعني كان كل اللي قدرت اقوله ان اكتوبر ولعت، اكتوبر ولعت.
It was Sunday and I heard emergency fire at October complex platform, and I cannot forget this because I know that there's more than 30 people working at the platform.
النار دي ما فيش حد كان يتخيل ان هو ممكن هيخرج منها بسلام، لان كل الناس اللي هي موجودة كانت متخيلة انها ميتة.
فطبعا كانت يعني منظر بشع. فطبعا اول حاجة خدناها ان نخلي المكان من الناس. طبعا كله نزل واتجه على البوت الا عدد قليل، يعني تقريبا كان موجود 6 تقريبا.
كان لازم نلحق الفاير قبل ما البريشر يوصل جوه الجهاز للزيرو بريشر. ليه؟ لان كان في اللحظه دي ممكن يحصل حاجه احنا بنسميها باك فاير، الحريق ممكن يخش جوه السيبريتور.
كان ممكن ان المحطه كلها تنفجر في لحظه ولا واحد من اللي موجودين دول يبقى ليه اثر على البلاتفورم.
كان طبعا في البدايه انا كنت حاسس ان نسبه النجاه ضعيفة جدا 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 في البداية. لما بدأنا نشتغل الحمد لله يعني حسيت ان بدأت نسبة النجاة تزيد شوية.
The fire took 2 hours to bring under control. Millions of dollars of damage was caused and a minor oil spill was released into the sensitive waters of the Gulf. But nevertheless, the October platform had been saved from what could have been a disaster comparable to Piper Alpha. As the smoke cleared, the incident investigation team started their work.
The big challenge is to get the lesson learned from these mistakes to avoid recurrence. October complex fire is a good example for that, and there is a lot of lesson learned.
After the October incident, a lot of corrective action have been taken from our part. The most important ones mainly related to the establishing of the OIM system, educating people to know how to isolate the energy, reviewing all the emergency plans for the offshore platform, doing a lot of drills for the people working on there. Very important to empower people to shut down the operation once they feel they are facing an emergency.
GUPCO has also revised the permit to work and isolation procedures and is conducting safety management system audits to provide assurance that safe work practices and procedures are being followed. For those who actually fought the fire, there were many personal lessons that had been learned and could now be passed on.
الشغلانة دي حضرتك اتعملت أكتر من 100 مرة. مفيش فيها اي مشكلة، لان معظم المشاكل بتيجي من الشغل الروتيني مش من الشغل اللي اول مرة يتعمل، لان الشغل الروتيني بيبقى الناس اللي بتقوم بيه بتعتمد على ان هي الشغلانة دي تمت 1000 مرة وتمت 100 مرة ومفيش فيها مشكلة، وبالنسبة له الموضوع ايزي خالص ومفيش فيه اي مشكلة. لكن بينتج ان بيحصل خطأ شخصي او خطأ بشري او خطأ غير مقصود من ايا كان في اي، سواء في الاوبريشن سواء في المينتنس سواء في اي حاجه.
اول حاجه ان لازم اتاكد بنفسي ان من الجوب دي اول حاجه. طبعا لازم التزم بالبروسيدر. تالت حاجه ان البروسيدر دوت يكون مطابق للحاجه الاكشوال اللي هي موجوده فعلا.
Happily, unlike the survivors of Piper Alpha, the crew of the October platform have no deaths to mourn. Nevertheless, for everyone in the Egypt BU, this fire, which came close to costing many lives, will never be forgotten.
الواحد روح البيت اكتر من 10 ايام ما يقدرش ان هو يتكلم ولا يقدر ان هو يرد على اي حد ولا يقدر ان هو يتعامل مع اي اسئله او على اي اجوبه، نتيجه ان حس في لحظه ان هو كان ممكن ان هو حياته كلها تنتهي.
هو طبعا كان الواحد مش يعني كأن في غيبوبه او يعني فقد الوعي. حاجه مش متوقعه ان يحصل حاجه بالشكل ده، فكان الوقت قدام الواحد الدقيقه كانت طويله جدا، فكان الواحد يعني حاسس بحركه غريبه،
لان المنظر بتاع الحريقه قدام عينيا والمنظر بتاع الحريقه مش عايز يضيع من عينيا، والمنظر دون بيخليني افكر ألف مليون مره ان انا ما يحصلش ان انا اعتمد على اي حد في اي حاجه. لازم انا بنفسي اتأكد 1000 مرة ان قبل ما اشتغل ان كل حاجة تكون مظبوطة وتكون كما يجب، ولو في 1% من اي شك في اي شيء اوقف الشغل خالص.
That incident was serious, extremely serious, but it could have been much worse. There are major differences between what happened on the October complex and Piper Alpha, but there are also some frightening similarities. The lessons learned from the October complex incident are lessons that need to be learnt by all of us and apply to all forms of energy in all environments. So, 2 tragic fatalities and a terrifying near miss. The common theme is that in each case the energy source had not been isolated. A prop under the truck body, a fuse removed from a circuit breaker, and every valve shut and locked correctly was all that was needed. Before you start any job, think of the golden rules of safety and ask yourself, what energy forms will I encounter and how can I isolate them? How will I secure the isolation? Have I released any stored energy? And how often should I check that my isolation is secure? Use the rules, check and be safe. If you have any doubt, don't even start the job.